Okay, next is our task number 2, and here we're going to be dealing with TE metrics on the Autoroute Announce forwarding method. We've used Autoroute Announce multiple times in the previous videos, but we haven't really paid attention how the metrics itself actually gets calculated and how the method influences the tunnel to be utilized. So here we're going to kind of look into this particular forwarding method in a little bit more detail. Okay, so first we need to reconfigure the MPLS TE tunnel 1 that we have already configured in our task 1 to use the Autoroute Announce, and then observe how the routes to R7 loopbacks have changed. Okay, so before we actually start the configuration, let's take a look at our routing table real quick and see what it looks like. So right now, the router R1 has 2 equal cost paths that points towards R7 loopback interfaces, and those paths are pointing whether it's towards R4 or R3. Okay, so currently R1 has equal cost path pointing out in 2 different directions. Okay, and we also want to take a quick note that the metric is 40 for those. So now we're gonna enable Autoroute Announce on the tunnel with the command tunnel MPLS Traffic Eng Autoroute Announce, and then if you go back and do show MPLS Traffic Engineering tunnel 1. And as I mentioned in the previous video, when you deal with the Autoroute Announce method, the metrics of the tunnel is actually calculated, or is basically equal to the metric of the shortest path. So even though that you see right here that the pathway of the tunnel is shown up as 30, but once you enter the Autoroute Announce command in there, the tunnel metric is actually equal to this one right here, 20. Okay, and because of that, if you do show IP route ISS one more time, you see that these 3 routes right here that belongs to R7 loopback is now preferring tunnel 1. Okay, and the metrics itself is still 40. Okay, let's spend a little bit of time to understand how the router came up with a metric of 40, which apparently is equal to what we saw earlier with the IP path right here, 40, but the tunnel has completely replaced those routes. So currently the tunnel between R1 and R2 is going through R5. That's why the pathway of the tunnel showed up as 30, but with the Autoroute Announce, it's equal to the shortest path. Shortest path from R1 to R2 is only 2 hops, so that's why it's 20. So this tunnel metrics itself with Autoroute Announce is only 20, and then that interface right there add 10, and then because the fact that the subnet we're trying to get to is in the loopback of R7, that adds another 10. Okay, so you add those 3 metrics together, you get 40. Okay, and this is the default behavior of the Autoroute Announce. Now next we need to reconfigure the MPLS TE tunnel 1 to have the metric of 30, and then observe how the routes to R7 loopbacks have changed. So basically, instead of using the default behavior of the shortest IGP metrics, which is 20, we're going to change that and set that the tunnel metrics to be 30. And the way to do that is on R1, we do interface tunnel 1, do tunnel MPLS Traffic Eng. Under the auto route, or part of that option, there's another option called metric. And with the question mark, you actually get 3 separate options here. But if all you need to do is to change the metrics on the tunnel itself, then you can just enter the metric right here, which is 30. Okay, so do show IP route ISS one more time and see how that affects the routing decision on R1. You can see that the R1 no longer used tunnel 1 to get to R7 loopbacks. Okay, and this is because we bumped up the metrics of the tunnel to 30, so the cumulative path cost to get to that destination is now become 30 plus 10, which is 50, and that's obviously higher than the IGP metrics that belongs to the IP path, okay, which is 40, and that's why the tunnel 1 is no longer used. And that's how you manually set the tunnel metric, which overrides the default behavior of the Autoroute Announce. Okay, next we need to reconfigure the MPLS TE tunnel 1 so that any routes reachable beyond the tail end router R2 has the metrics of 10, and then observe how the routes to R7 loopback has changed. Okay, so what that particular task is asking us to do is for any routes that's reachable through this tunnel, so that's anything beyond the tail end router, in this case it's R2, so that includes this particular link right here, that directly connected link, that particular link, and anything beyond that router. So that would be R2 loopback, R7 loopbacks also. And we want all of those routes to show up on the head-end router, router 1, with the metric of 10. So going back to our configuration for our auto route metric, here we are already trying to use the first option. With the next option, an absolute, this is exactly what it's going to do. So if you use the absolute option, what it's going to do is it's going to hard code the metric for any routes that's reachable past the tail end router to the values you specify right here. So here we want it to be 10. Okay, now if we do show IP route ISIS one more time, you can see that all of these routes that I mentioned are the directly connected subnet of the router R2, and anything beyond that now showing up with the metrics of 10. Okay, and obviously this includes all the R7 loopback interfaces before. Let me scroll up to the routing table. We had it with the metrics of 40, that's part of the IP path, and now we overrode the tunnel or the path metrics of 10, which is absolute value, so it doesn't basically take into account the additional metrics right here on the interface or the loopback interface itself. So it's just hard code the metrics of those routes to the value of 10, and 10 is obviously less than 40, and that's why the tunnels are being preferred. Okay, so that's basically the behavior when you specify the metric using the absolute option. Next, we need to reconfigure the MPLS TE tunnel 1 to have higher metric than the shortest IGP path by 5, and then observe how the routes on R7 to R7 loopback have changed. Okay, so at this point we know that the shortest IGP path from R1, so let me kind of delete all that again, from R1 to R2, okay, so you can actually go through R3 or R4. Those are two equal cost paths, and these has the metrics of a cost of 20. And the task set that we want to set the tunnel 1 metrics to be higher than that 20 by 5, so that means that we have to set it to 25. Again, we have a tunnel right here. We want to set that to be 25. Obviously, you can use the command that we did previously to hard code the tunnel metric to 25, but if when you trying to make the change or configure the metric that's slightly more or less than the shortest IGP path, what you can do is to use the relative option. So let me kind of do up arrow, and right here that's our third option for setting the metric. And when you do relative, it allows you to go either higher or lower by 10. Okay, so as long as you want to make it slightly different within that range, you can use the relative option. So here we just want to set it higher by 5. So we can do metric relatives and make it a positive value of 5. Okay, so by doing that, the default tunnel metrics of 20 has now just been increased to 25. And now if you do a show IP route ISIS, you can see that the router R1 stops using the tunnel 1 one more time, because once that becomes 25, again you have that to be 10 and another 10 for the loopback. Adds all that up together, gives you 45, which is higher than the IP path of 40. And that's why the router stops using the tunnel. Oh, and also I kind of forgot to show you the show command with the show MPLS. Let me do this. Get out of that. Show MPLS Traffic Eng, and there's a Autoroute option that you can do. When you press enter, you can see that for tunnel number 1, currently the metric has been set to a relative metric of 5. Okay, if we do an exact same show command for what we did earlier with the absolute command, it would show up right here as an absolute, and then whatever metrics you set for the tunnel. Alright, so those are basically the 3 options, or 3 ways that you can set the metrics on the tunnel that has the Autoroute Announce configured. Okay, next we have to reconfigure the MPLS TE tunnel 1 so that R1 load balance traffic to R7 loopbacks between the IP path to R4 and the tunnel 1. Okay, so what we want to happen right now, since we have the tunnel that goes from R1 to R2 through R5, and then we also have the IP path right here this way, we want the R1 to be able to load balance the traffic towards R7 between those 2 paths. And if you remember, right at the beginning of task number 2, when we turn the tunnel or make the tunnel start using Autoroute Announce, when you look at the routing table on R1, all it's using is the tunnel 1, and it doesn't really load balance between the 2 paths, even though that the path metrics for both were 40, okay, but just because the path metrics for the IP path and the tunnels were equal doesn't mean that the router will start installing the equal cost path for those, and this is because there's a intersection between the tunnel and the IP path, and that's the default behavior, so it's just going to always prefer the tunnel when there's always intersection. So what we're going to have to do is to reconfigure our tunnel so that it doesn't really extend all the way to router 2, and that way the tunnel and the IP path does not intersect. So what we're going to do is to basically remove the last hop right here from our explicit path. So the tunnel is now going to terminate on the router R5, and then we're going to have to make sure that the path from R1 to R2 through the tunnel has the cost of 20, which is equal to what R1's going to see when it's trying to get to R2 through R4, because there's only 2 hops, so that would be a cost of 20 as well. Okay, just remember that the last hop right here adds 10, and that adds another 10. Alright, so first we need to modify our explicit path to remove the link from R5 to R2. So we're just going to go ahead and come up with a new explicit path for that, and we're going to name it R35 enable. Next hop 3 and 5. Okay, and then tunnel 1, we're going to have to modify our tunnel destination to R5. And then tunnel MPLS traffic eng, update our path option 1, explicit name R35, and then let's make sure that the tunnel comes up, so show MPLS traffic eng tunnel. Okay, so right now our tunnel terminates on router R5, and let's do the tunnel 1 at the end as well, and it says that the shortest path for R1 to get to R5 right now is going to cost 20. Okay, so obviously if the tunnel itself costs 20 and then you add extra 10 right here, the whole path from R1 to get to R2 through the tunnel is going to be 30, so it's still higher than IP path on top right here, which is 20. So what we're going to have to do is to somehow lower IGP metrics of the bottom path so that it makes the accumulative metrics for the path equal to 20. So right here, what we're going to do, I mean, there's a different way that you can do this, and this is just one of the way that we choose to do. So what we're going to do is to change the ISI's metrics right here in the R3 interface, adjust it down to 5, and same thing for the outgoing interface of R5, we're going to make it 5. Okay, so that way, when you have metrics of 10 on R1, 5 on R3, and the other 5 on R5, when you add them together, it gives you 20. That way, from our perspective of R1, it will see the top and the bottom path having an equal cost, and it should start load balancing. So hop over to R3, and that would be the interface S0010. We'll set the metrics to 5. Okay, and then for R5, it'll be 000:0. Okay, ISS metrics 5. Okay, so now if we go to R1 and then do show IP route ISIS, you can see it doesn't really take effect. So let's take another look at our tunnel, traffic engineering tunnel again for the TU one. You can see right here the path weight from R1 to R5 for the shortest path has been adjusted down to 15. So the tunnel right now has the metrics of 15, and then when you add that with the 5, that should give us 20, which is equal to the cost of the path in the top. So I'm not sure why it's not load balancing yet. Well, let's take another look at the tunnel configuration. Maybe we forgot something. It could be this line right here that we have added a relative metrics of 5, so that might have made the path cost of TE tunnel higher than the IP path. So let's try to remove that line right there. Okay, and then do show IP route one more time. And okay, there you go. So we're now starting to see tunnel 1 being used for these routes. And since now that we have 3 equal cost paths that router can use to get to R7, but our task right here clearly specify that we only need to load balance between the IP path to R4 and tunnel 1. So obviously we have an extra path right here that's going through R3 and then R2 that we need to get rid of. Since this path right here also gives you the path cost of 20, what we can easily do is to bump up the metrics right here. And again, there's multiple ways of doing this, but the easiest way is probably bumped up the metrics from 10. Default, we're going to make it 20. And just to make that path less preferred, so on R1, actually it's going to be on R3, and that will be serial 020, and let's adjust that to metrics of 20. Okay, so that's going to make the whole path end to end increase from 40 to 50, so R1 should no longer prefer that. And now if we do a show command of that, you can see that we no longer see R3 as our next hop, okay, for the IP path. Okay, and we should now be load balancing between the two paths, although we can't really test that, but let's just make sure that R6 do have connectivity. So we're going to test from our router R6, do a maybe trace routes to 7701, sourcing from loopback 10, and let's see which path it takes. So it went from 13527. So it goes from 13527. That means for that particular trace route, the packet actually got sent over the MPLS TE tunnel. Okay, so that should pretty much complete our task number 2.